Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Class 10, subject physics, chapter number 12, geometrical optics we are doing. Topic of today's lectures are 12.6 and 12.7, and we will cover the pages 45, 46, and 47. If you open the class textbook 45, we are going to start, and then we will cover 46 and 47 page. Class 10, subject physics, chapter number 12, geometrical optics. Topics of today's lecture 12.6 and 12.7. We have already done part of 12.6, but we will continue from optical fiber. 12.6 continuation topic, optical fiber. Page number 45, 46, and 47. This is the chapter we are doing, unit 10, 12, geometrical optics. Name of the chapter is geometrical optics, unit number 12. So we have discussed about application of total internal reflection last time, and we were studying optical fiber. Now we continue with the optical fiber, this one, which I'm pointing towards. Optical fiber. So optical, if you see the optical fiber figure, so you can see this figure, it has two parts. One is called the core part and one is the cladding. So refractive index of the core is greater, but the refractive index of the cladding is smaller than the core. You should be very important. You should note this very importantly. Total internal reflection is using fiber optics. So we have studied the total internal reflection. I told you in my last lecture the phenomena of total internal reflection. So whenever the angle of incidence is greater than the critical angle, so instead of the light going back to the rare medium, it come back to the denser medium again. So all the light is tending towards the denser medium. So it is not going to the rare medium. This phenomena is called the total internal reflection. So we will study the application of the total internal reflection. So total internal reflection is very important. Optical fiber, total internal reflection is using fiber optics, which has a, this is a fiber optics, right? Optical fiber, number of advantages in telecommunication. These fiber optics, these fiber optic cables are used in telecommunication field. Telecommunication field means to communicate to communicate with the far distances. This is called telecommunication field. Like the phone. Phone is the telephone is the telecommunication field. So we use in telecommunication fiber optics cables are used. Fiber optics are used in the telecommunication. In fiber optics we use the total phenomena of total internal reflection. Fiber optic consists of hair-sized thread of glass or plastic through which light can travel. It is the fiber optics is like our hair. If you take your hair and calculate its thickness is very thin. So you can say that optical fiber is consist of hair-like structure. It is a combination of many hairs. So if you combine these, this will form the fiber. If you combine the thickness of fiber optics is like your hair, thickness of your hair. So the light travels from this. The signal travel from in the form of light in the fiber optics. So the inner part, it has two parts. The fiber optics has two parts. One is called the core part, and the other one is called the cladding. I explain you now. The inner part of the fiber optics is called core. This is the core, the round shape through which the light is entered into the fiber optics. This is called the core. Where I'm pointing, the circle one is the core through which the light is entering. Optic is called core that carries the light, and an outer concentric shell is called cladding. So this one is called the cladding. You can see it is written over here, cladding, right? The core is made of glass or plastic or relatively high index of refraction. I told you N, the index of refraction. The core is refractive refractive index of the core is higher than that of the refractive index of cladding. So core has a higher refractive index. Light entering from one end of the core strikes the core. So light is entered from one end of the core and strikes the cladding. You can see it is entering from here and it is strike the cladding. This is the cladding. So because the total internal reflection is takes place, so what happened? This light go back to the same medium. Before, instead of it is going out, it goes into the same medium. Look, you can see this is entering, and instead of it is going out in the air into the air medium or air, so it goes into the same medium. It is going into the glass medium. So this phenomena is called total internal reflection. So in this phenomena, we send the light, give the light this some critical angle in which incidence angle is greater than critical angle. So what happened when the incident angle is greater than critical angle, as we have discussed in last lecture? So our all the light is, instead of going out, it goes into the same medium. This phenomena is called total internal reflection. In this way, light travels many kilometers with small loss of energy. Why we are using the optical fiber? Because we don't want to make our data loss. So, in order to, because if we are not using fiber optics cables, we are using some other cables. So where loss will be heavy. But if we are using fiber optics cable, we are using we are sending our signals in the form of light. So in the form of light, and signal is not lost. It is going very fast. So that's why we are using fiber optics. The advantage of fiber optics cable is this, that it has a small loss of energy. Where we use it, actually, so where we use actually in Pakistan. In Pakistan, optical fiber is being used in telephone and advanced telecommunication systems. So you have seen the PTCL or telecommunication systems. We use this optical fiber cable because if you want to use them in internet purposes, but because in internet purpose we use fiber optics to receive or send our pages. Since suppose we want to open the Google page, so if you write down Google www.google.com, so it is coming after 2 minutes. What will happen? So you will see you will not use the internet. You will say it takes 2 minutes to open the Google page. So you will be fed up and you will leave it. So what you actually do, use the optical fiber cables, so communication becomes fast. So that's why our Google page is opening very quickly, and our other pages are opening very quickly. This is the reason we use the fiber optic cables. If the pages are not responding quickly, we will not use the internet service. So in telecommunication field, or if there is a disturbance, if you are calling someone and your voice is cutting, and the other person is not hearing your voice, so what will happen? You will you will you will not call me. The reason behind it, he cannot hear you and you cannot hear him. So in order to make the disturbance free medium, to use the optical fiber cables, because our in optical fiber cables our signal is travel in the form of light. So we send the signal in the form of light. So by the process of total internal reflection, there is a less loss of energy, and we can get the faster communication. That's why in the reason behind using the optical fiber is for the fast communication. So mainly telecommunication field and telephone, we use the optical fiber cable. Next is light pipe. What is light pipe? Explain you. This is on page number 46 of your 10th class textbook, 46 page. What is light pipe? Light pipe is a bundle of thousands of optical fiber. In light pipe, this is a light pipe. So in light pipe, we use the bundle of thousand of optical fibers. We use optical fibers in light pipe. Where we use the explain you. Okay. Light pipe is a bundle of thousands of optical fibers bounded together. They are used to eliminate the inaccessible places by the doctor or engineer. For example, doctor view inside the human body. They can also be used to transmit images from one place to another place. So this is the use of the light pipe, where we actually use the light pipe. The doctor mainly use the light pipe. Why they use it to see the condition of the organs, whether it is a bad or good organs, not the good organ, the bad organ. In order to examine the bad organs, they actually transmit the signal through light pipe, and then they can view it on. You can see this figure. They can view it on the monitor screen. So light pipe is a bundle of thousands of optical fibers bounded together. They are used to eliminate the inaccessible places by the doctors or engineers. For example, doctor view inside the human body. If they want to see which organ is bad, lungs is bad, kidneys are bad, in order to view, they can. Uh, if they don't use this, they will have to do the surgery. They have to open the body of your body. By opening the body, they don't open the body. They use this light pipe to view which organ is bad one, so they can view on the screen. They can view on the screen with the help of this light pipe. So I explain you what is endoscope now. This is made of fiber bundle. This is a project images, transmitted image, and lens. So I'll explain you in endoscope how they use this in endoscope. An endoscope is a medical instrument used for exploratory diagnostic and surgical purposes. An endoscope is used to explore the interior organs of the body. Suppose interior organs of the bodies are what are the interior organs, like the heart, lungs, kidneys. These are the interior organ of the body. If there is a problem in the interior organs of the body, what the doctor do? There are the two methods. One method is to rip off your body. So rip off your body, that is called the surgery. So in first of all, they do the surgery, and they rip off your body, and then they examine what is the problem in your organ. Which organ has a problem? Lungs they have the problem, kidney has a problem, or heart has a problem. But instead of ripping off your body, what they use the process called endoscope. They use the instrument, medical instrument, which is called endoscope. Instead of opening their body, they actually insert the pipe into your body, this light pipe into your body, and examine what is the problem with your organ. If there is a problem in your organ, they send the light. The signal is sent to the light, and when it strikes the organ, the defective organ, uh, the light coming from the defective organ can be seen on the monitor screen. The defective organ can seen by the on the monitor screen. So doctor, with the help of this, doctor can examine your organ condition of organs instead of going into the surgery. This is the advantage of endoscope. Due to its small size, it can be inserted through the mouth. It can be this endoscope can be inserted into your mouth by in order to examine your body organ through the mouth, and thus eliminate the invasive surgery. So If you use it, you don't need require any surgery, because in surgery you have to doctor has to open your body, to rip off your body. So they don't do this. They use this endoscope medical instrument to insert through your mouth and can examine the organ, different organs in your body. The endoscope used to examine the, so there are the three types of endoscopes. The stomach, the endoscope used to examine the stomach, bladder, and throat. The endoscope which is used to examine the stomach is called the gastroscope. The endoscope used to examine the bladder is called cystoscope. The endoscope which is used to examine the throat is called bronchoscope. So there are the three types of endoscope. The endoscope which is used to examine your stomach. If they want to examine the stomach condition of the stomach, they use gastroscope. So if they want to examine your bladder, they use the endoscope cystoscope. The name of the bladder to examine the bladder is cystoscope. To examine the throat, this is called bronchoscope, respectively. But the old procedure is called endoscopy. An endoscope uses two fiber optics tubes through a pipe. A medical procedure using a type of endoscope is called endoscopy. All the process, whether they are examining the stomach, whether they are examining the bladder, or whether they are examining the throat, this process is called endoscopy. What happened in endoscopy? The light shines on the organ of the patient to be examined. For example, they want to examine the stomach, so they will use the gastroscope. So a medical procedure using a type of endoscopy. The light shine on the organ of the patient to be examined by entering through one of the fiber tubes of the endoscope. Then light is transmitted back onto the physician viewing lens through the other fiber or tube by the total internal reflection. So, so this is the transmitted image, and this is the one image. So we send our light through its fiber optics with the so what is the involved? This is total by the total internal reflection. The light goes strike on the organ and it comes back, and doctor can see on the monitor. So they can see the condition of stomach, or they can see the condition of the kidneys, heart, anything. So with the help of this, they transmit the signal, and after striking the organ, it comes back to the doctor's monitor, where they can examine the different organ of the body, whether they are good one or bad one. Then light is transmitted back to the physician viewing lens through the other fiber tube by total internal reflection. Flexible endoscope have a tiny camera attached to the end, and doctors can see the view protected by the camera on a computer screen. Since on one end of the endoscope there is a small camera attached, so the doctor can see the view of the or of the organs with this small tiny camera. So this is the endoscope and light pipe. So we just studied about the optical fiber. So optical fiber, where we use actually optical fiber, we use optical fiber in the field of telecommunication, like the phone calls we receive nowadays. So this is just because of the fiber optics and the internet signals, or internet incoming coming in our houses is through the optical fiber, because it is a fast way for the communication. Here the signal is traveled with the in the form of light, and it travels many kilometers without any loss. So this is the advantage of the fiber optics. So fiber optics cable has two parts. One is called the core, another one is called the cladding. The core, the light enters through the core, and where incidence angle is greater than critical angle, whenever the incident angle is greater than critical angle, this light will strike and will go into the same medium instead of going outside. That refractive index of the core is greater than the refractive index of the cladding. So you should know now There are the two parts of the fiber optics. One is called the core, through which the light is entered, and other one is called the cladding, through which the when the light enters from the core and it strikes the cladding, it goes to the same medium instead of going outside. This phenomena is called the total internal reflection. So we studied this one. Then we studied light pipe. The doctor used light pipe to examine the different organs in our body, to examine the bad condition of the organs, whether they are bad. So, instead of using the invasive surgery, they don't go for the surgery. They use this endoscope procedure to examine the internal organ of the body. So endoscope is basically three types. The endoscope which is used for stomach to examine stomach is called gastroscope. The endoscope which is used for examining bladder is called cystoscope, and the endoscope which is used to examine throat is called bronchoscope. This all, whether we are using stomach, bladder, or throat, this process is called endoscopic. The doctor enters this light pipe into our body through our mouth. Through our mouth, there is a tiny camera attached on it. So the signal is sent, and this is the phenomenon of total internal reflection occurs. And with the help of the tiny camera, doctor can view uh, the image of the organ on the monitor screen. This procedure is quick and is very important because it eliminates the invasive surgery. In surgery, you have to rip off, doctor has to rip off your body, but doctor don't go for ripping off your body. They go for endoscopy. They insert the pipe into your mouth and examine the different organ in your body and view it on the monitor screen. This is the advantage of the endoscope. We don't go for the surgery. This is the advantage. We don't go for the surgery. We go for the endoscopy. The doctor insert the pipe into the body through the mouth. So this is the end of the topic 12.6. Now we are going to start 12.7. And 12.7 is refraction through prism. So refraction through, I show you the prism now. Refraction through prism, which is on page number, if you open page number 46, you can find refraction through prism. How refraction occurs through prism. Prism is a transparent object made of optical glass. You should know this is made of optical glass with at least two smooth plane surfaces inclined towards each other. If you look at this is the prism. So this is the one surface, this is the other surface. Light, this is called incident light, and after reflection, after passing this light coming from their medium and enter to the other medium, which is called the glass, and you can see the uh, direction of the incident ray. The light from the rare medium enter to the denser medium. This is called denser medium, and after entering from the denser medium, when it leaves it, so this is the emerging rays. This is called the emerging rays. So I explain you now refraction through a triangular glass prism. This is a triangular shaped glass prism. It is made of glass. This is called triangular because it has three angles, one, two, three. That's why it is called triangular glass. It is made of glass. That's why it is called triangular glass prism. So from which light is reflected. In case of triangular prism, figure 12.717, the emergent ray is not parallel to the incident ray. This is the emergent ray. Fs is the emergent ray. So this is not parallel to the incident ray. You can see if they are parallel, like if you see the tracks of the railway tracks, you can see they are parallel. But these rays, incident ray and the emergent ray, they are not parallel. It is deviated by the prism from its original path. So original they have deviated. They are not parallel, they are deviated. The incident ray PE makes an angle of incident height. Look, PE, this is the PE and it is making angle I, which is called incident angle at point E. It is making angle E at point E, and it is refracted towards the normal N E F. This is refracted. It has because it is passing from rare medium to denser medium. It has been refracted, and the refracted part is called EF. The refracted ray EF makes an angle R. So you can see this is making an angle R. R is the angle making angle with an normal with the EF. The refracted ray EF makes an angle R with the normal inside the prism and travel to the other face of the prism. This is the first face. AB is called the first face, and AC is called the second face. So prism has two faces. One is called AB is the first face, and AC is the second face. So he's saying normal inside the prism and travel to the other face of the prism. The ray emerges out from the prism at point of. Look, you can say this is emerging out. This is called emergent rays. FS is not parallel to the incident. As I have already told you, PE is not parallel to FS. A ray PE but is deviated by an angle which is called the angle of deviation. So if you proceed this, if you draw the normal, this dotted line shows that's the normal. If you draw the normal, this is called the deviation, angle of deviation. Student, you don't need to worry much about it because there is an experiment uh, regarding this prism. So when we do the experiment, you hopefully understand this. So you should not be very much worried about it. So now we uh, move towards topic 2.8 lenses, on page number 47. So we in my previous lecture we discussed about concave mirrors. We discussed about mirrors. So mirror has two types: concave mirror and convex mirror. Now I have already told you that we will study the lenses as well. Okay. So and now we are going to study lenses, and 2.8 topic is 2.8 on page number 47. Lens is a transparent material. These are the types of lenses. These are the convex lenses and these are the concave lenses. I show you now. So why this is called, these are the types of convex lenses have three types. What is called double convex, plano convex, and concave convex. So lens is what is the difference between lens and the mirror? So you know in mirror I talked about one surface is polished and other surface is deflecting. I told you, but in mirror you can see through. See through like the lens in lens you can see through. Like the lens are used in your eyeglasses, you use the lens. So in eyeglasses you can see on both sides. So you can see through this is the difference between lens and mirror. In lens you can see through, but in mirror you have one surface is reflecting while other surface is polished. This is the main difference. Lens is that any transparent material having two surfaces. It has two surfaces, of which at least one is curved. So one is so in this case, double convex because two surfaces are convex. That's why this is called double convex lens. So lenses reflect light in such a way that image of the object is formed. Lenses of many different types are used in optical devices. They are used in cameras, eyeglasses, microscope, telescopes, and projector. Where we use actually the lenses, we use the lenses in cameras. Cameras lenses are used, eyeglasses, microscopes, which we will study, telescope we will study, and the projector we use the lenses. Where actually the use of lenses, we use the lenses in cameras, eyeglasses, microscope, telescopes, and projectors. They also enable millions of people to see clearly and read comfortably. If someone has a bad eyesight, so they use the glasses. So these lenses enable the people to see clearly and read comfortably. Types of lenses. So there are different types of lenses. The lens which causes incident parallel rays to converge at a point is known as convex or converging lens. I will show you in a minute. There is a different types of lenses. I told you there is a convex lens. The convex lens has three types: double convex, plano convex, and concave convex. Concave. Why I am saying double convex? Because two sides are curved. Here one side is plane and other side is curved. This is called plano-convex. Here one side is concave and one is convex. One side is concave and one is convex. That's why this is called concavo-convex. So similarly, concave lenses have two types. Why I'm saying double concave? Because two sides are concave. One side is concave. This side is concave. This is called double concave. But here one side is concave, other one is plane. This is called plano-concave. One side is straight, another side is concave. That's why it is called plano-concave. The other one side is concave and other is convex. One side is concave. The inner one is called concave. The outer is convex. This is why this is called concavo-convex. We have two. When we studied the mirror, we said convex mirror and concave mirror. But when we study the lenses, we have convex lenses and concave lenses. So convex lenses have other three types. So in convex lens, we have three types: double convex, plano-convex, or concavo-convex. But if we talk about concave lens, so it has three types: double concave, plano-concave, or convexo-concave. So, and the type of the lenses, because the parallel light of ray diverges from a point, this is called concave or diverging lens. This is the other name of the concave lens is diverging lens. The other name of the convex lens is converging lens, because after reflection, I will show you in a minute. After reflection, after passing through the lens, they meet at the rays of light meet at a point. This is called converging lens. So the other name of the converging lens is convex lens. Okay, concave lens when the rays of light passing through the lens and they diverge, they do not meet at a point. They diverge. This is called concave lens. Other name of the concave lens is diverging lens. The This is called the concave or diverging. The other name of the concave lens is diverging lens. The lens is thin at the center and thick at the edges. Figure 12.19. So concave lens is basically thin at the center. It is thin at the center and thick at the edges. So similarly, when I talk about the convex lens, it is thick at the center but thin at the edges. So this is the difference between. So we have two lenses: convex lens and concave lens. Convex lens has three types. Concave lens has three types. Convex lens is called converging lens. Concave lens is called diverging lens. I show you what is the difference between converging lens and diverging lens in short. Lens terminology, I told you: principal axis. Each of two surfaces of spherical lens is a section of a sphere. The line passing through the two centers of curvature of lens is called principal axis, as I told you earlier when we studied the mirror. So same thing is principal axis is same as that of in lenses. The optical center, a point on the spherical axis at the center of lens, is called optical center. Same thing as we discussed in mirror topic. So I show you now. I told you this is called convex lens is called converging lens. When the ray of light the ray of light is passing through it, and after passing through the lens, convex lens, this is called double convex lens. So after passing through this, it is meeting at a point. This point is called focus point. So ray of light parallel to the principal axis. So these rays are parallel. You know, this ray is parallel to this ray is parallel to this ray is parallel to this. So whenever the light passing through the center, it will not deviate. Okay, it will not deviate. But if the rays of light is passing through, look, this one after passing through the lens, it is converging at a point and it is deviating. Look, this light is after passing through the lens, it is meeting at a point. But this, when the ray of light is passing through the center, it will not deviate. It will go straight and it will meet at a point F. Look, this is a parallel light. When pass through the lens, it will be meet at a point. Similarly, this is meeting at the point. That's why the convex lens other name is converging lens, because after passing through the lens, they are meeting at a point. Then principal focus. I have already told you in the mirror therapy what is principal focus. Same. Why we are saying Focal length, I have already told you what is the focal length. This is the distance between the optical center and the principal focus. So from here to here, this is called small f. You can see small f. So a small f is a focal length, and a capital F is the focus point. So from center to this point, the distance from center to the focus is called focal length, and focal length is noted with small f. Focal length is denoted with small f. Why we say concave lens? The other name of the concave lens is diverging lens. What happened when the rays of parallel rays of light passing through the concave lens, after passing through the lens, they are not meeting at a point. You can see they are meeting at a point. That's why it is called converging lens. But in this case, they are not meeting at the point after when the ray of light passes through the lens, and they are diverging. They are not meeting at the point. They are diverging. This is called. That's why the concave lens is called diverging lens. So you can see focus will be lie on the both the sides of the lens, here and here. Here f will be here, f will be here, center will be here. So my focus point is lying on both sides. Similarly, my focal length will lie on the both sides. So you can see this concave lens is called diverging lens. Why I'm saying diverging lens? When the parallel rays of light enter through the lens, they do not meet at a point, but they diverge. So they seems to meet at a point on the other side, but they are actually the ray of light is diverging. So that's why the other name of the concave lens is diverging lens. Students, this is the end of the topic. In my next topic, we will study about diopter, waves, the other topic, power of lens, in our next topic. But if you have any question regarding what we discussed today, you can ask me freely. Thank you. So we discussed actually optical fiber. If you have any question regarding today's topic, you can ask me freely. Please ask freely and don't feel hesitation. Thank you. Please unmute your mic and ask questions. In my next lecture, we will do the MCQs test of chapter number 10 and 11. You should memorize this. Uh, 10 and 11 chapter, we will conduct the MCQs test in my next lecture. So please become prepared with these the MCQs we did, and the extra MCQs inside the chapter we will discuss. I will ask a question and you will raise your hand, and whom I ask, you will have to answer. So make sure your headset and mic is working properly. In the next lecture, we are conducting the MCQ test of chapter number